For this question, we want to graph the inequality y is less than or equal to x squared minus 2. This is considered to be a nonlinear inequality. And what we do is we graph this type of inequality in two parts. We start by graphing the boundary. And the boundary is going to be the inequality, but replacing the inequality symbol with an equal symbol. So this will give us a boundary line, and it will divide up our plane into two sections. So we could graph this in a bunch of different ways. You're going to be doing it in MyMathLab, so you have to use the tools that they offer and the graph that they offer. So one way I would do this without MyMathLab, if I was just doing it by hand, would be to think of this as our polynomial x squared graph, our parabola, and the minus 2 shifts it down too, so then I could get a sketch of the graph. You're going to draw the sketch of that graph with a solid line. And you draw it with a solid line because the inequality includes this equal to. Now with MyMathLab, you have to use the tools that are available, and the tool that they give you is a button that's a parabola, and it has 2 points listed, so we have to plot 2 points. It might even be 3 points. I can't remember exactly. So you have to make sure that you click that button and then you click points that are on the parabola so that it draws the parabola. The student who asked me this question was having an issue with plotting the intercepts. They were specifically trying to plot these intercepts, but the grid doesn't allow for you to plot those intercepts because they have a radical in there. So you have to choose points that are going to give you nice whole numbers. So maybe we choose -1, 0, and 1. And -1 squared minus 2 would be 1 minus 2, and that's -1. You can see that point right there. 0 squared minus 2 is 0 minus 2, that's -2. So we have this point here. And then 1 squared minus 2 is 1 minus 2, and that's -1. And we have this point here. So that's drawing the boundary line, and then of course considering the restrictions of graphing with MyMathLab. You may not be able to do it the exact way you would do it by hand. Once you've drawn the boundary line, you can see that this line breaks up the plane into two sections. We have this section here, which is sort of above the line, and this section here, which is below the line. And we need to decide which one of those we're going to shade. You're going to shade the side that makes the inequality true. So to decide which side that is, we choose a test point. And most people like to choose 0, 0 as the test point because it makes for really easy simplification. And you substitute that into your inequality. 0 is less than or equal to 0 squared minus 2. 0 is less than or equal to -2 is a statement that is false. 0 is not less than -2. So that tells me that the points that are above this curve in that first section are not solutions to the inequality. The other side will be true, And so we're going to shade the true side. So all of the points that are shaded, all of the ordered pairs that are shaded, and the ordered pairs that are on the boundary line are ordered pairs that make this inequality true. For this example, we want to expand the expression using binomial theorem. The expression we're expanding is x minus 3 to the 4th power. I've taken a screenshot from our notes over here, which gives us the formula for binomial theorem. And the formula for binomial theorem has a summation, and it's got this notation here, which is a combination formula. And we have x. X is the first term in our binomial to a power, and that power changes. It starts high and then goes low as we go through the summation. And then we have a here. A is the second term in our binomial. And it's going to start low. It's going to start with 0 and move all the way up to n as we go through the summation. So using this formula, we're going to be able to expand the expression without multiplication. So without having to do our FOIL method of multiplication. So the first thing that we should notice is that this has a minus instead of a plus. So we really want to think of this as x plus negative 3. So that the x in our formula is x, and our a in the formula is negative 3. So we're going to do that binomial expansion using that x and a. So let's write out the binomial expansion. We're going to do the sum of j equals 0, and n in this example will be 4, since we're raising our expression to the 4th power. And we're going to have n, which is 4, and j is our variable inside the sum. We have x to the 4 minus j, and negative 3 to the j. Now, if we want to follow the formula literally, we would evaluate the summation. We're going to start with j equals 0 and substitute that in. That would give us, for our first term in the summation, 4 choose 0, x to the 4 minus 0, negative 3 to the 0. Then I'll move on and increment j by 1, and that would give me that would be n choose 1, n is 4, x to the 4 minus 1, negative 3 to the 1. Incrementing j again, we would get 4 choose 2, x to the 4 minus 2, and a, negative 3 to the 2. We would increment j again and have 4 choose 3, x to the 4 minus 3, negative 3 to the 3. And we'll increment j one final time. And that would give 4 choose 4, x to the 4 minus 4, negative 3 to the 4th. So using that binomial theorem, we have a few things to simplify and work out. We need to work out what 4 choose 0 is. This is going to be using our combination formula. And we need to simplify these expressions here as well. So we have x to the 4th power, negative 3 to the 0 power would be 1. And I'm going to work out this 4 choose 0 on the side over here. So let's work out on the side, we're going to work out 4 choose 0. Some people would write this as 4C0. And we have a formula for this. N choose R, or NCR. And the formula is n factorial over n minus r factorial times r factorial. So we would have 4 factorial over 4 minus 0 factorial times 4 factorial. Sorry, that would be 0 factorial. And this would be 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. 0 factorial is defined to be 1, so this works out to be 1. We worked out that combination formula to be 1. So for that first term, we get x to the 4th. So then we're going to work out the next combination formula. 4 choose 1, that's 4C1. That's 4 factorial over 4 minus 1 factorial times 1 factorial. It's 4 times 3 times 2 times 1. 4 minus 1 is 3. 3 times 2 times 1. And 1 factorial is 1. So the 3, 2, 1 cancels out, and we get 4 for this term. So we have plus 4 times x cubed, and negative 3 to the 1st power would be negative 3. And this is a minus 12x cubed for that next term. Okay, so then let's work out the next one. Going to need a little bit more space, so let me zoom out a little bit more. So let's work out 4 choose 2, or 4C2. That's 4 factorial over 4 minus 2 factorial times 2 factorial. That's 4 times 3 times 2 times 1. 4 minus 2 is 2. 2 times 1. And 2 factorial is 2 times 1. So we could cancel out 2 and 2, make 4. So we have 3, 2, 1, that's a 6. So this 4 choose 2 works out to be a 6. 6x squared. Negative 3 squared is 9, so we get 54x squared. Okay, so let's work out the next one. We get 4 choose 3. 4C3 would be 4 factorial over 4 minus 3 factorial times 3 factorial. That's 4 times 3 times 2 times 1. 4 minus 3 is 1. 1 factorial is 1. 3 factorial is 3 times 2 times 1. So we get 4 after we reduce. So 4 choose 3 works out to be 4. We have 4x to the first power, negative 3 to the third power would be negative 27. So I've got to do 4 times negative 27. And that works out to be a negative 108, negative 108x. Okay, finally we're going to work out 4 choose 4. Or 4c4, that's 4 factorial, over 4 minus 4 factorial times 4 factorial. That's 4 times 3 times 2 times 1. 4 minus 4 is 0 factorial. 4 times 3 times 2 times 1. 0 factorial is 1, so this works out to be 1. That's 1 times x to the 0, and negative 3 to the fourth would be 81. X to the 0 is 1, so this works out to be a plus 81. So we've expanded that binomial. Now I would like to show you one more efficient way of getting this worked out. You can see most of our time was spent working out these combination formulas. And we have something called Pascal's triangle, which can allow us to get those coefficients a lot faster. So with Pascal's triangle, you start with a 1 at the top of your triangle, and you're going to write 1s. You're building a triangle, or sort of like a pyramid. So you're always going to have 1s along the edges. And I'll add 1s along the edges for the third row, but in the third row, we're going to have a number in the middle here, and that number we get by taking the two numbers that are above it and adding it together. So that's 1 plus 1, which is 2. When we create the next row, we're going to have the 1s on the edges, and we're going to get 1 plus 2 is 3, and 2 plus 1 is 3. And then we'll go one more. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And what you can see here are the same numbers that we got when we did our binomial, our combination formula just a little while ago. So these are the same numbers that we got. Now you need to know which row to use. When we raise to the 0 power, we use the first row. To the first power, the second row. The third power, the second power, we use the third row. The third power, we use the fourth row. And the fourth power uses the fifth row. And you'll know if you're using the right row based on how many terms your expression should have. The number of coefficients should match the number of terms in your binomial expansion. Find the vertices and the foci for the ellipse. Graph the equation. We have the equation x squared over 16 plus y squared over 9 equals 1. So this is an equation of an ellipse. The first thing that I like to do is to try to figure out the orientation of the ellipse. So while we try to figure out the orientation of the ellipse, we should take a look at what an ellipse's equation looks like. We have two versions of two orientations that we're looking at in this class. One of them is a horizontal orientation, meaning that the ellipse is going to be longer horizontally, and a vertical orientation, which means it's going to be longer vertically. And as we look at these two equations, they look very similar to each other. We have x squared over a squared plus y squared over b squared equals 1, and x squared over b squared plus y squared over a squared equals 1. The only difference between them is in the first equation, a is under the x, and in the second equation, a is under the y. So that must have some kind of significance with our orientation. So what exactly is a and b within our ellipse? So a is going to be the distance between your center and your vertex. And it's going to be longer on the longer side. So A is the longer of the two numbers, or the larger of the two numbers. B is going the perpendicular direction to that, and it's going to be sort of the width on the shorter side. So looking at our problem again, I can see that the larger number is under the x. So that means that I'm going to get my a from the larger number. And it also tells me that we have a horizontal orientation. I know that a squared is 16 and b squared is 9. So I know that a is equal to 4 and b is equal to 3. Now, once I know the orientation, I want to know what the center of the ellipse is. And you can get the center of the ellipse by looking at inside the squared next to the x and inside the squared next to the y. In this particular example, there are no numbers added or subtracted, and HK inside of that is our center. So since we have no numbers added or subtracted, we know that our center is going to be 0, 0. So we have a center of 0, 0, and we know we have a horizontal orientation, so we're going to be able to find the vertices. I typically like to draw it out. I think better visually like this. So we have a center. Our center is at 0, 0. We are oriented horizontally, so I know the vertices are going to be horizontal from the center. I'm going to go 4 to the right and 4 to the left, and that's going to get me to the vertices of this ellipse. That's at the ordered pair 4, 0 and negative 4, 0. We have vertices at negative 4, 0 and 4, 0. We also want to find the foci of the ellipse, and the foci are found using C. So if we have an ellipse and we go from the center to the left and right, if we're horizontally oriented, we're going to go C units to the left and C units to the right. That's going to get you to your foci. So in order for me to do it for this problem, I have to know the values of C. So I'm going to use this equation, b squared plus c squared equals a squared. So 9 squared plus c squared equals, excuse me, I did that wrong. That should be 3 squared plus c squared equals 4 squared. 9 plus c squared equals 16. I'll subtract 9. That's c squared equals 7. So c is equal to the square root of 7. So my foci are going to be square root of 7 to the left and square root of 7 to the right of the center. So that would be negative square root of 7 comma 0 and square root of 7 comma 0 for the foci. The final bit in the directions is that we want to graph. So I'm going to count up by 3 because the value of b is 3. I'm going to count to the right and left 4 because the value of a is 4, and I'm going to connect those points to graph the ellipse. We want to find the equation for the ellipse, graph the equation, and we're given some properties about the ellipse. It has a center at 0, 0, a focus at 15, 0, and a vertex at negative 17, 0. So the first thing that I like to do is to try to figure out the orientation, because once we know the orientation, we'll know which base equation to use. So when you're looking for the orientation, you want to figure out whether you have an ellipse that is oriented horizontally or an ellipse that's oriented vertically. So when an ellipse is oriented horizontally, the center will be in the middle, of course, and then two important features will lie horizontally along where the center is. So you're going to have vertices that lie on that horizontal line, and you'll also have foci that lie on that horizontal line. So if you have your center, your focus, and your vertex lining up horizontally, you know you have a horizontal orientation. When your orientation is vertical, you'll have those important features lining up vertically instead along the same vertical line. So if I think about the given information, I like to put it on a graph. We have the center at 0, 0. We have 15, 0. So let's count by 5s. 5, 10, 15, 0 would be our vertex. We have center in the vertex. Excuse me, that's the focus. I apologize. 15, 0 is the focus. And then we have a vertex, 5, 10, 15. So we would have negative 16, 0 being a vertex. So you can see our center, vertex, and focus are lining up on the same horizontal line. So we know we have a horizontal orientation. Okay, so we know the horizontal orientation. And let me get a screenshot of the equations that we're going to be working with. Excuse me, that was a bad screenshot. Let me get a better one. So these are the equations of the ellipse. And we just figured out that we're going to have a horizontal orientation. So our equation is going to follow either this format here or this format here. These are both horizontal orientations. And the difference between them is the first one has the center being at 0, 0, and the second one allows for a center to be somewhere else on the graph, some HK. Now we do have our center at 0, 0, so we can use this simplified version of the equation. And if we want to write what the equation is, we have to know what A and B are. Now, in our picture of an ellipse, A is going to represent the distance between the center and the vertex. So remember, we had the center at 0, 0 and a vertex at -17, 0. So that distance is going to be 17. So we know the value of A. We don't know the value of B because the value of B is how wide the ellipse is, the shorter side. And we weren't given any information about that. We were given the foci. So the value of C is the distance between the center and the foci. So we have a center at 0, 0 and a foci at 15, 0. That's a distance of 15. And since we know C and A, we're going to be able to solve for B. So B squared plus 15 squared is equal to 17 squared. B squared plus 15 squared, that's 225, equals 17 squared. 17 squared is 289. I'll subtract 225 on both sides, and we get B squared equals 64, and I can square root both sides to get B is equal to 8. And now that I know the values of A and B, I can write the equation. So the equation of the ellipse will be x squared over 17 squared. And we already found 17 squared to be 289 plus y squared over b squared, and b squared is 64, equals 1. So we have the equation of the ellipse, and then finally we want to graph the ellipse. And I've already got most of the graph here. I really just want to make sure that I add in what is symmetric. So because we have a vertex at -17, 0, we're also going to have a vertex at 17, 0 because of the symmetry of ellipses. And now that we know the value of B, I can go to, I'm counting by fives again, that's 5 and 10. So we know how wide on the shorter side the ellipse will be, about 8 up and down. And we can connect those vertice points and draw a sketch of the ellipse. For this question, we want to find the partial fraction decomposition of the following rational expression. The rational expression is 22 over x times x squared plus 11. And so first of all, we want to know how to set up the decomposition. And when you set up the decomposition, you want to have your denominator in factored form. Luckily, this one is already factored for us, and it is factored completely. And then what you do is you examine each factor and decide what type of factor it is. There are really only about 4 categories that you're looking for. You're looking for linear and quadratic, and, within that category, you're looking to see if it is repeated. Because if it's repeated, you do something slightly different. Now, the 2 factors that we have a factor of x, and this is x to the first power, making it a linear factor. And then we have x squared plus 11, and this is a quadratic factor. And it's a quadratic because it's squared. And neither one of them are repeated. Now, just so you would know what it would look like if it were repeated, repeated would have maybe a squared here or a cubed here. So these are not repeated. So for each one of the factors, you have to create the decomposed fraction on the other side. So for the linear factor, you're going to put that linear factor in the denominator, and a linear factor will have a constant as the numerator. Then you're going to have a factor or a fraction for the quadratic factor as well. However, a quadratic factor will have a linear factor in the numerator. And I want to make sure that I use different coefficients, different variables for those constants. And we're going to have to figure out what A, B, and C are for this partial fraction decomposition. So this is our setup for that. And now we're going to work on finding that A, B, and C. Now to find that A, B, and C, what you do is clear fractions. You're going to multiply both sides of the equation by this denominator on the left, and that will clear out all the denominators. We're going to have 22 on the left, because it cancels the denominator, equals A times x squared plus 11, because the x is canceled out, plus bx plus c times x, because the factor of x squared plus 11 cancels out. Now, we have this equation, and we're going to use this equation to figure out the values of A, B, and C. Now, there are several ways that you can go about finding the values of A, B, and C. 2 of the strategies that we learned in class are something called equating the coefficients, and the other way is choosing strategic values of x. So we're going to start with choosing strategic values of x, and I'm going to use this right here, this value of x, to help me figure out what value of x to choose. I want to choose whatever zeroes that factor out. So I'm choosing x equals 0, and if I plug it into this equation, I should get a true statement. 22 equals A times 0 squared plus 11 plus B times 0 plus C times 0. So that cancels a bunch of stuff out and makes it easier for me to figure out the value of A. You have 22 equals A times 11, and all of this is 0. So we're going to divide both sides by 11, and we find that A is equal to 2. Now, we don't really have any other strategic values of X to choose, so I'm going to use the other method going forward, the equating the coefficients method. Now, with the equating the coefficients method, I guess I can go ahead and put that value of A in. We found it to be 2. What we want to do is use a distributive property and collect all of the like terms together. So this would give 2x squared plus 22 plus bx squared plus cx. I'm going to group the x squared terms together. That's 2x squared plus bx squared. I'm going to have the x terms together, and then also the constants together. And what equating the coefficients means is that you're going to take the like terms on the left and match them with the like terms on the right. Now you'll notice that on the right we have an x squared term, but we don't have an x squared term on the left. So that means that the coefficient of x squared on the left is 0, and 2 plus b has to equal 0. On the right-hand side, we have a coefficient of c on the x term, and we don't have an x term on the left. So that means that that has a coefficient of 0, so c equals 0. And the constants, we really don't need to worry about them because there's no variables there. We have 22 equals 22. But with this information, we can now find b and c. So by subtracting 2 on both sides, we see that b is equal to -2 and c is equal to 0. So now that we know the values of a, b, and c, we can write out our template of the partial fraction decomposition as a was 2, so 2 over x. B is -2, that's -2x over x squared plus 11. And c was 0, so I left that off of the numerator. So we've now found the partial fraction decomposition for 22 over x times x squared plus 11. On this question, we want to write a formula for the nth term of the geometric sequence. The geometric sequence we have is 5, 10, 20, and 40. And I pulled a screenshot from our notes because we have a formula for finding the nth term of the geometric sequence. And that nth term is a sub n equals a sub 1 times r to the n minus 1. A sub 1 is the first term of the sequence, and r is the common ratio. So the first term of the sequence is 5. So we know that's our a sub 1. And we need to figure out the common ratio. The common ratio is where we take consecutive terms and divide them. So let's take the first term and the second term and divide those two numbers. 10 divided by 5 is 2. If I take the next two consecutive terms, that's 10 and 20. 20 over 10 is 2. And the next two consecutive terms, 40 and 20, that's 2. And that's the reason why it's called the common ratio, because every pair of consecutive or successive terms is going to have this ratio. So we know that R is 2. So we can write the nth term of our sequence as 5, that's our first term, times our common ratio of 2 to the n minus 1 power. And then we can test out so that we can feel comfortable and confident that this is the right sequence. A sub 1 would be 5 times 2 to the 1 minus 1. That's 5 times 2 to the 0. 5 times 1 is 5, so we got the correct first term of the sequence. The second term is 5 times 2 to the 2 minus 1. That's 5 times 2 to the first power. 5 times 2 is 10. So we got the correct second term of the sequence. 5 times 2 to the 3 minus 1, that's 5 times 2 squared. 2 squared is 4, 5 times 2 is 20. We got the correct third term of the sequence. And we'll just check one more. 5 times 2 to the 4 minus 1, that's 5 times 2 cubed. 5 times 8 is 40. We got the appropriate fourth term of the sequence as well. So the nth term of the sequence 5, 10, 20, 40 is 5 times 2 to the n minus 1. On this one, we want to find the fifth term and the nth term of the geometric sequence, whose initial term, a sub 1, and common ratio are given. We're given the initial term, or first term of the sequence, to be negative 3, and the common ratio to be 2. So what we know about geometric sequences is that we can use that common ratio to get to the next term in the sequence. So I can find the second term of the sequence by taking the first term and multiplying it by the common ratio. So that's going to be negative 6. I can keep doing this process until I get to the fifth term. So a sub 3 will be the second term times the common ratio, and that's negative 12. The fourth term will be the third term times the common ratio. Negative 12 times 2 is negative 24. And the fifth term, that's the one we are looking for, is the fourth term, negative 24, times the common ratio, and that's negative 48. We also want to find the nth term of the sequence, and we have a formula for the nth term, and that formula is the first term times the common ratio raised to the n minus 1. So the first term is negative 3 times the common ratio of 2 to the n minus 1. This is our nth term, and we can also check to see that we did that fifth term correctly. Let's check n equals 5, and we get negative 3 times 2 to the 5 minus 1. That's negative 3 times 2 to the 4th, and 2 to the 4th power is how much? Let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, and negative 3 times 16 is negative 48. So we get the same answer with both methods. So we found the fifth term of the sequence to be negative 48, and the nth term of the sequence to be negative 3 times 2 to the n minus 1. For this question, we want to find the indicated term for the arithmetic sequence. We want to find the 100th term of the sequence 7, 14, 21, and so on. Now the 100th term is quite large of a term, so even if we see a pattern here with these numbers, it might be too much work to try to count it out to get to the 100th term. So I do see a pattern here in that we have 7, 14, 21. It looks like we have multiples of 7 here. So the next one would be 28 and 35 and so on. But as I said, counting out to the 100th term is just not convenient. So instead of counting out to the 100th term, we'll find the nth term of the sequence. This is going to give us a formula for finding that nth term, that 100th term of the sequence. Well, the formula for the nth term is a sub n equals a sub 1, that's the first term of the sequence, plus n minus 1 times d, where d is the common difference. So we do know that the first term of the sequence is 7, and if we take the difference of consecutive terms, 14 minus 7 would give me 7. 21 minus 14 would give me 7. We can see that we have a common difference of 7. So let's plug that into our formula to get the nth term. 7 plus n minus 1 times 7 gives a formula of 7 plus 7n minus 7, and that's 7n. So if we want to get the 100th term of the sequence, that would be 7 times 100, which is 700. So the 100th term of the sequence, 7, 14, 21, and so on, is 700. An arithmetic sequence is given. Find the common difference and write out the first 4 terms. The arithmetic sequence is defined by the nth term here, 2 minus 6n. And we want to know the common difference. So there are a few different ways that you can figure out the common difference. So one is to take a look at that formula for the common difference. Make that a little bit smaller. So here's the formula, and let's look at where the common difference shows up in the formula. We have it here, and if you have this in simplified form, you would distribute this to the n and distribute it to the 1. So I'm focusing in on this part here with the n, and notice that the coefficient of the n is -6. So we're going to have the common difference being -6. So whenever you have an arithmetic sequence, if you want to identify the common difference, it's going to be the coefficient of that n. If you're thinking of this as a linear equation, it's going to be like your slope. It's not the only way for us to figure out the common difference. Let's write out the first 4 terms of this sequence, and I'll show you another way for us to figure out the common difference. So we want to write the first term of the sequence by substituting a 1 in. That's 2 minus 6 times 1. That's 2 minus 6, which is -4. The second term of the sequence, 2 minus 6 times 2, is 2 minus 12, and that's -10. Then we have the third term, 2 minus 6 times 3, That's 2 minus 18, which is a negative 16. And the fourth term of the sequence is 2 minus 6 times 4. That's 2 minus 24, which is a negative 22. So we've written out the first 4 terms of the sequence. So another way for us to find the common difference is to take the difference of successive terms. So take terms that are right next to each other and calculate the difference. Negative 10 minus negative 4 is negative 10 plus 4, and that's negative 6. I'll take the next 2 successive terms. Negative 16 minus negative 10 is negative 16 plus 10, and that's negative 6. And I'll take the next pair of terms. Negative 22 minus negative 16. That's negative 22 plus 16, and that's negative 6. So you can see that every pair of successive terms has the same common difference of negative 6. So this is another way to identify that the common difference is negative 6. In this example, we want to write out the sum. We have the sum of k plus 9 from k equals 1 to n. More specifically, we want to write the first, the second, and the last terms of the sum. The first term of the sum, we use this lower bound number here. We want to take this number and plug it into our expression, and that's going to generate the first term in our sequence, the first term in our sum. So that would be 1 plus 9, which is 10. That is the first term in our sum. Then we increment this number by 1. And if we increment that number by 1, it would become 2, and I'll plug 2 in for the k. That would be 2 plus 9. And the second term in our sum would be 11. And then we're going to continue with this pattern until we get to our final number, our upper bound, which is n. And we plug that number into our sequence, and the last term of our sum would be n plus 9. Can't do any simplification on that, so the last term is n plus 9. Thank you for checking out my videos. Have a great day.